In the previous lesson, we learned about how we can represent chemical reactions in the form of chemical equations. I'm sure you found that interesting. Just think about it. How complex chemical reactions can be written in the form of small chemical equations. And moreover, these equations get all the more interesting as we keep on learning about them. In this lesson, we'll cover up one important aspect about chemical equations, that is balancing of chemical equations. Now, before I get to explaining this topic, let me just remind you something that we had learned earlier in the previous class. We learned about law of conservation of mass, right? What does this law state? Do you remember? This law states that mass can neither be created nor be destroyed in a chemical reaction. Now, don't get confused. Mass, chemical reaction, it just seems so much of it. In simple words, what this actually means is that the number of atoms on the left-hand side for each element is equal to the number of atoms of the same element on the right-hand side. To understand this balancing of chemical equations better, let us quickly take an example. Let us take a few pieces of zinc and add it to a diluted solution of sulfuric acid. What happens is that zinc is reacting with sulfuric acid to give us zinc sulfate along with hydrogen. Right, so let us quickly go ahead and write the chemical equation of this reaction. Right, so we have zinc plus sulfuric acid giving us zinc sulfate plus hydrogen. So in terms of chemical equation, this would be Zn plus H2SO4 will give us ZnSO4 plus H2. Right, now let us just go ahead and tabulate the number of atoms for each element on the reactants side and on the products side. So firstly, let us start with zinc. On the reactant side, we have one atom. On the product side also, we have one atom. So that's balanced. For sulfur, we again have one atom on the left hand side. We have one atom on the right hand side. That's again balanced. For oxygen, we have 4 atoms on the left hand side and we have 4 atoms on the right hand side as well. That's again balanced. Lastly, that is hydrogen. Now hydrogen, we have 2 atoms on the reactant side and we have 2 atoms on the product side. Again, this is equal. Now luckily, this reaction happens to be balanced. One molecule of zinc is reacting with one molecule of sulfuric acid to give us one molecule of zinc sulfate along with one molecule of hydrogen. Well, we were fairly lucky in this case. The chemical reaction was balanced. However, luck is not always going to be by our side, is it? Let us quickly take an example where the reaction is not balanced and we will have to balance that chemical equation. Right now, what do you think happens when iron reacts with water? What happens is that ferrous-ferric oxide is formed along with hydrogen. Let's go ahead and write down the chemical equation. We have Fe plus H2O giving us Fe3O4 plus H2. Now, as we have done earlier, the first step to balancing a chemical equation is to write down the number of atoms for each element on the reactant side and on the product side. So let's go ahead and do that. For iron, we have 1 atom on the left hand side. However, we have 3 atoms on the right hand side. For oxygen, we have 1 atom on the left hand side. However, we have 4 atoms on the right hand side. For hydrogen, we have 2 atoms on both the sides. Right? So that's fairly balanced. Right, now the second step that I want you to do is to go ahead and draw boxes around each compound, just as you can see over here. Now, why do you think I'm asking you to draw these boxes? The primary reason I'm doing this is to simplify and explain the concept of balancing. In balancing, we cannot alter the composition of the molecule. What I mean by that is that H2O cannot be written as H2O4 just for balancing the chemical reaction. H2O4 will be a different compound altogether. But in this reaction, water is the compound that is reacting. So whatever balancing will happen outside these boxes. No composition inside the box will be changed. Now, having said that, the next step for balancing a chemical reaction is to identify the element which has the highest number of atoms. Now this element could be on either the reactant side or the product side. That doesn't matter, right? But the element needs to have the highest number of atoms. So in this case, clearly oxygen is the element. It has 4 atoms. That's the highest number of atoms. Now that we have identified oxygen as the element, let's quickly go ahead and balance that. So we have 4 atoms of oxygen on the product side and we have 1 atom of oxygen on the reactant side. Now to balance this, we want to make the number of atoms on the reactant side also 4, right? So what we will do is that we will write 4 outside the box next to H2O. What this essentially means is that 4 molecules of H2O will be reacting in this reaction, right? So now quickly let's go ahead and alter the number of atoms for oxygen in the table. Right now, what do you observe? Now you will observe that while we were balancing oxygen, the number of atoms for hydrogen got misbalanced. Now there's nothing to worry about. This often happens in chemical reactions. Now what next we will do is we'll go ahead and balance hydrogen. Right now, so on the reactant side, we have 8 atoms of hydrogen, but on the product side, we have 2 atoms of hydrogen. Now as we did earlier, we need to balance this. We need to ensure that there are 8 atoms of hydrogen on the product side also. So what we'll do is that we'll write 4 next to hydrogen on the product side. Now what this will mean is that there are 4 molecules of hydrogen present in this reaction. Right now again we have 8 atoms of hydrogen on the reactant side and we have 8 atoms of hydrogen on the product side. So that's again fairly balanced. As you can observe in this reaction, hydrogen and oxygen are 2 elements which are balanced now. The last element which needs to be balanced is iron. Now as you can see, for iron, we have 1 atom of iron on the reactant side, but we have 3 atoms of iron on the product side, right? So as we have done earlier, what we'll go ahead and do is that we'll write 3 outside of iron on the reactant side. So now we have 3 atoms of iron on the reactant side and we have 3 atoms of iron on the product side. So now this is fairly balanced. Now I want to quickly break down this chemical equation for you. What does balancing exactly mean? What it essentially means is that 3 molecules of iron are reacting with 4 molecules of water or H2O to give us 1 molecule of ferrous oxide along with 4 molecules of hydrogen. I hope it is clear and I hope you have essentially understood this concept. If not, please feel free to ask me anything under the doubt section of this video and I'll answer it as soon as I can. Now, this chemical reaction fairly looks balanced, doesn't it? The number of atoms are equal for each element on the reactant side, on the product side. However, there is one thing that is missing and I'll talk about that. It is essential for us to give out maximum amount of information possible through a chemical equation. Have a close look at this chemical equation. Does this say anything about the physical state of each compound in this chemical reaction? It doesn't, right? Well, let's go ahead and add it. Now, before we do that, in this lesson, there are 4 types of states that we'll be essentially learning about, right? The first is solid, the second is liquid, the third is gaseous, the fourth is aqueous. Now, I think we all know about the first 3 states, right? Solids, gases, liquids. We've learned a lot about these in our previous classes. However, I just want to quickly talk about aqueous. What exactly does aqueous mean? Aqueous means nothing but a substance being present in a solution of water is a state known as aqueous. Having known the different types of states, let us quickly go ahead and add the states of each compound in this chemical reaction. So iron is present in the form of solid, so we'll be writing S in small brackets next to iron. H2O in this reaction is present in the form of gas, so we'll be writing G in small brackets next to H2O. Fe3O4 in this reaction is present in the form of a solid. So we'll write S next to Fe3O4 in small brackets, and hydrogen is evolved in the form of gas. So we'll write G again in small brackets next to hydrogen. So students, this is how we balance chemical reactions. I hope you've clearly understood the balancing of chemical reactions. If not, in case you have any doubts, please ask me anything you want to know about in the doubt section below this video, and we'll quickly address any of your doubts.